Hi everyone! So in today's video we're going to be talking about the conservation of mass, particularly how to do the calculations. Now what we're going to do first is we're going to just recap what the conservation of mass means, and then we're going to be looking at some calculation practice. So the conservation of mass, this is derived from Lavoisier's work that he did in the late 1700s, which basically states that the total mass at the beginning of a reaction equals the total mass at the end of the reaction. So whether we're talking about a chemical reaction or whether we're talking about a physical reaction, the total mass of all of your reactants will equal the total mass of all of your products. So whenever we're looking at a calculation question scenario, it's actually quite simple. We need to basically calculate the total mass of our reactants, and then we compare that to the total mass of our products. And basically the total masses need to be identical. So using this concept, if we're given all of the substances in a chemical reaction save for one, we can actually figure out how much was used or produced. So if we're looking at our first series of questions, we're asked for which one represents the law of conservation of mass. And we need to remember that the total mass at the beginning of the reaction has to equal the total mass at the end of the reaction. And the reaction that we're talking about can either be a chemical reaction or a physical reaction. So if I'm looking at the first one, melting 10 grams of aluminum gives 8 grams of melted aluminum. Well, 10 and 8 are not the same numbers. And if we're looking at our total values here, it should be 10 and 10. So A is not an example of the conservation of mass. If we look at the second one, 4 grams of hydrogen reacting with 32 grams of oxygen. So if we're looking at this right here, or 4 grams of hydrogen and our 32 grams of oxygen would be our reactants. So if we add them together, 4 plus 32, we get 36. And do we have 36 grams of water produced? Yes, we do. So this is an example of the law of conservation of mass. If we look at the next question, a glass of water containing 22 grams of dissolved salts evaporates and leaves 20 grams of salt. This is not an example because if it were, we should have 22 grams remaining. Our salt does not evaporate with the water. If we look at D, burning 24 grams of carbon with 64 grams of oxygen gives 84 grams of carbon dioxide. Well, in this question, our 24 grams of carbon and our 64 grams of oxygen are our reactants. So if we add them together, and if this is showing conservation of mass, we should have a total of 84. But in actuality, we get a total of 88 grams. So because it is not the same, this is not an example. Now let's look at our last question. A plant that absorbs 264 grams of carbon dioxide and 108 grams of water, so this are our reactants, produces 180 grams of sugar and 192 grams of oxygen. Well, the first thing that we need to do is we need to add our two reactants. So if I add them, 264 plus 108, I get a total of 372 grams. Now, if this is showing the conservation of mass, then that means when I add 180 plus 192, I should get 372. And if I add them together, guess what? I do get 372 grams. So in our 5 examples here, only B and E show conservation of mass. So what we're actually going to do now for the next couple of questions is look at some typical practice questions and how to figure out our unknown quantity. So in our first question, we have 12 grams of carbon reacting with 32 grams of oxygen to produce carbon dioxide. The first thing that I need to do is I need to write this down in a word equation. And what that means is I need to write down all of my reactants on the left-hand side of my yield and all of my products on the right-hand side of my yield. And I can actually get a lot of clues based on the words that are used in the question. So when I see carbon reacting with oxygen, well, the word react is a mental sign for a plus sign. And when I see produce carbon dioxide, well, the word produce is a mental note for drawing the yield sign. So if I'm taking this question and I'm breaking it down into a word equation, I get something like this. Carbon plus oxygen yields carbon dioxide. That's step one. Now step two is I basically, underneath all of my substances, I write down the masses that I'm given. And if I'm not given a mass for that particular substance, I write down X. So underneath carbon, I would put 12 grams. Underneath oxygen, I would put 32 grams. And underneath carbon dioxide, I don't know it, so I would put X. Now I evaluate. Carbon and oxygen are both my reactants, and due to the law of conservation of mass, the sum of my reactants is going to be equally the sum of my products. So X would be 12 grams plus 32 grams, giving me 44 grams. All right, let's look at the next question. In this question, we have the following. 160 grams of rust is produced when 112 grams of iron reacts with oxygen gas. Now here, it's actually written backwards. My iron and my oxygen gas are not my products, but my reactants. And how do I know this? Because if I'm looking at the beginning of the question, it says 160 grams of rust is produced. So the rust is my final product. So my word equation looks like this. Iron plus oxygen yields rust. Just like the last time, now I write down all of my numbers that I have, and the substance that doesn't have a number, I put X underneath it. So I have 120 grams plus X gives me 160. So in this case, I'm actually working backwards. My total amount of my reactant side needs to add up to 160. So to find X, I'm simply doing 160 minus 112 grams, and I get 48 as a result. Let's do one more practice question. So in this one, I have the following. 58 grams of butane reacts, so my mental sign for plus, with 208 grams of oxygen when it burns. The reaction yields, so my yield sign, 176 grams of carbon dioxide, and, well, obviously when I see the word and, it's again mental sign for a plus sign, an amount of water vapor. So translating this into a word equation gives me the following. I write down the numbers that I have, and what I don't have, I put an X. So 56 grams of butane, 208 grams of oxygen, 176 grams of carbon, and a certain amount of water vapor. So my total mass of my reactant side will be equal to my total mass of my product side. So the first thing that I need to do is I need to figure out, and this is what I have right here. So I need to do 58 grams plus 208 grams, which gives me a total of 266 grams. And then I subtract that from 176, which is my carbon dioxide, and my water vapor amount is 90 grams. I hope this helps, and have a nice day.